welcome everyone. Today we are going to talk about how to turn your data into a graph. So I'm Jean-Pierre, one of the co-founders of Linkurious. We are a French startup located in Paris, and we specialize in graph visualization. Linkurious is working with customers like NASA, for example, the French Ministry of Finances, and various organizations around the world that are struggling to find meaning and answers in graph data. We help them visualize graph data and extract insights from it. Today, I'd like to talk about one of the common pitfalls of the organizations out there who are interested in finding answers in graph data. Most of the time, the data that these organizations have is not structured as a graph. It can be highly connected. They can be interested in finding and understanding relationships within the data, but the data itself is not structured as a graph. It can be stored in a SQL database, in a MongoDB database, in a simple spreadsheet, in anything really, but not necessarily a graph database like Neo4j, for example. So today, as a way to help these organizations and perhaps to help you, I'd like to explain how to turn a very simple spreadsheet into a graph stored in Neo4j and then visualize it with Linkurious. We are going to go through a very concrete example, and hopefully you will learn some skills in the process. So let's get started. We know that graphs are everywhere. Can be in the payment transactions, can be in IT logs, can be in a supply chain. The world is built around networks, and graphs are the best way to represent these networks and to understand them deeply. On a day-to-day basis, we interact with customers who are applying graph technologies for cybersecurity, for fraud detection, for knowledge management, or for impact analysis in large IT networks. And yet, sometimes the data that most organizations have is stored in simple spreadsheets. Here, for example, we are looking at a social network. Really, it's people connected to other people, and I can see that there's Maureen here, and she's connected to Fred. The data is great, it's structured, but it's hard to understand. Looking at these different lines, it's hard to understand who are the people and who are they connected to. Simply speaking, get a picture of what's going on here, and that's where graph visualization can be so powerful. The problem is that when you want to actually visualize graph data, there are a few steps that have to happen before. In most of the projects we see, there's a kickoff during which some objectives are set, during which the data is also assessed. Then there's a modeling phase during which experts model represents the data in a graph model according to the business objectives set in the kickoff stage. When the data is actually modeled, it can then be imported into a Neo4j database, and then when it's done, it can be visualized in Linkurious. The challenge here is that modeling data as a graph and importing it in Neo4j requires some skills which are not always possessed by those who are interested in visualizing the data. So today we are going to view through a simple example how to model and import spreadsheets. But first of all, I'd like to mention that there are a few options out there to import data into Neo4j. So there's the load CSV feature of Neo4j, which is relatively easy to use and can work with a CSV file, which is a great format that can a very common standard, I'd say, that can, for example, be be outputted by Excel, but also by various systems. It does have some drawback. The first one is that it's relatively slow compared to other options, and best limited to small data sets, really. It's also doesn't also handle very well the needs of incrementally updating a graph in production. Another interesting option is the batch import, also compatible with the CSV format. It's very fast and can handle big data sets. The only drawbacks of using that feature is that it's a bit harder to use than the load CSV option. And just like the load CSV option, it's best suited for an initial load versus an incremental load. So finally, there's the API of Neo4j, which is great when you want to increment, make updates really to an existing data set in production. Only drawback being that it's not well suited for an initial data load. So these are some of the options that as an end user you can have to load data into Neo4j, and they have different pros and cons, as you can see. To summarize, I'd like to sort of say that the load CSV feature is best to start quick and dirty, whereas the batch import is best for an initial load of a large data set for production system. And finally, the API is best used to keep updated a production system. So really, three options for three distinct use. Today, we're going to focus on the load CSV functionality, which is the easiest and that I use on a regular basis to try new data sets and visualize them with Linkurious. So let's get started. For today's webinar, we are going to talk about a very specific data set. It's related to transparency, and we are going to study the European public tenders. They happen to be available online, and it's great use case for a graph approach, let's say. So here's a quick screenshot. Some of you will recognize an Excel spreadsheet here. It's a very simple Excel file with different columns, different values, and that's all the data that we are going to work with today is formatted. So let's talk a little bit about what it is really that we are going to work with. So the data that we are going to visualize today and load into Neo4j is procurement notices available in XML format via the European Union Open Data Portal. The copyright of that data belongs to the Publications Office of the European Union. For those interested, there's a link here that leads to the portal. For convenience, we are going to focus on the open-TED version of that data, which is maintained in a CSV format. So open-TED is an organization, a non-profit organization, working to maintain an open approach to tenders, and as part of that mission, is maintaining a CSV version of the European tenders. The data that we will look at contains about 73,268 documents for 2015. That represents about 96,755 lines and 141 columns. So it's not a massive data set, but it's already too big, too complex to understand with a simple Excel spreadsheet or with a simple tabular approach, really. After the import, we will end up with about 161,539 distinct entities and 536,933 different relationships. So it's quite a big data set, really. So first, let me talk about the data model. Out of these 141 different columns, we have decided to extract a key set of entities and a key set of relationships. So the entities that we are going to be focusing on today are the authorities. So these are the organization, let's say, who are emitting the tenders. There are also delegates. So a delegate can be an organization that confers to an authority the role of setting up a tender for it. There are also appeal bodies. So for each public tender in Europe, an organization needs to set an appeal body. The appeal body is responsible for reviewing any disputes related to the good conduct of the tender. Finally, in our dataset, we are going to focus on the operators. So the operators are the companies awarded the tenders by the authorities. All these entities are linked with one another, and they are linked. The delegate, appeal body, operators are linked to the authorities, and the authorities, delegate, appeal body, operators are all linked to different contracts. So these are the entities that we are going to be focusing on today. So let's get started with the actual importation of the data. To import data in Neo4j using the load CSV functionality, one has to use a query language called Cypher. So Cypher is the Neo4j query language, and it enables end users, people, to interact with graph data. We are going to use it to do multiple operations. The first one being to create a few sets of entities. So here we are looking at a snippet of code which turn all CSV file into a few authorities. So the authorities are one of the key entity type that we identified during the modeling stage. Now we are going to actually create the authorities. For that, we simply read the CSV file and choose to create the authorities with the appropriate properties or values. So let's look at the actual snippet of code. First, there's create constraint on a double point authority assert a point official name is unique. So that's necessary to make sure that the authorities will be unique. We will not end up with duplicates, and it will also speed up the import. Then we can start with the actual importing of the data. So it's using periodic commit 2000 that sets a limit, a threshold between each commit. Then we have load CSV with headers from the name of the file as line. So that's a command to actually load a specific file. Yeah, it's TED contracts 2015.csv. and I'm adding the with headers to the command to later on be able to use the column names of that CSV file for simplicity's sake. Then there's a field delimiter, which is a simple comma. So here I'm specifying that my different values, my different properties are separated by commas, so that will help the load CSV functionality of Neo4j to identify the fields and make distinctions between them. Then there's with line, and where line point contract authority official name is not null. So that's specifying that we specifically want the lines where the contract authority official name exists. We want to discard every line where it's simply null, it doesn't exist. When all this preliminary work, we can actually create the authorities. To do that, it's very simple. It's merge a to point authority, so that creates a node which has the authority label, and we set a few key properties. So the official name of that node, the official name property of that node will be line dot contract authority official name. So it's very simple here. We are using the value situated in the contract authority official name column to create an official name property. So let's say that in line 1 we look at column contract authority official name, and we see the value Acme Corporation. We will create an authority with the official name Acme Corporation. So all this code does something very simple, which is to create authorities based on all the contract authority official names which are present in our data. With the same approach, we can, of course, create all the other types of entities. It's just a matter of choosing the right label and choosing the right column for each entity. So that's the first step, which is to create the distinct. It's also important not just to create them, but also to populate these entities with relevant properties. So for example, here we can see a snippet of code adds a number of properties to the authority nodes. So to do that, the code is fairly simple. It's on create set, and then it's a dot number of contracts of contract equal 1, a dot total value cost euro equal 2 int line point the dot contract total value cost euro. So we are here, for example, creating a property which is total value cost euro, and assigning it the value of the total value column within our data. To int, we make sure to turn that value into an actual number to be recognized as such by Neo4j. We can do that for all other properties. And what is interesting here is that the result is that all entities, like for example the authorities, will not only just have a name, they will also have these different properties added to it as a way to enrich the data. So an authority, for example, will have a total value contract, will have a number of contracts, and that will help us better understand the data. So that was second key aspect of loading data into Neo4j, which is adding properties to nodes and to edges. I'd like now to talk about yet another aspect of the data importation. Not only can we create some properties out of the data which is in our spreadsheet, but we can also do some smart aggregations. So that can be useful to enrich the existing data by computing some interesting properties. So, for example, here we can see that just like earlier on, we saw that on create set we did a bunch of operations. Here we have an on match set and then a list of operations. So the on match set command means that these different computations will be executed only when an existing node or an existing edge is found. Here we are incrementing a number of contracts. So if number of contracts property is already found in our data, let's say that Acme Corporation has already one contract. Then that number of contracts will be incremented by one next time a new contract is identified. So it's very simple. Set a dot number of contracts equal a number of contracts plus one. With the same logic, really, we are also incrementing the total value cost euro, the contract value VAT included, and so on and so on. So it's very easy to do this kind of computations using the load CSV functionality of Neo4j. Finally, after having done all these data import, there's still something very important to do. It's to create the actual relationships between these distinct entities. So let's talk a little bit about that. To create the distinct relationships between the entities, we are going to use the snippet of code which is on the right side of the screen. So it's very similar to the code that we use to create the different nodes. So there's the using periodic commit 2000. Then it's the load CSV command. It's field delimiter comma. So these are all things that were written that we used to import the nodes. The next few lines are the first. We try to match to identify, let's say. So it's match official name line contract authority official name. So it's this cipher requirement is going to accomplish one thing. It will try to find an existing node which has as an official name the value present in the line of a spreadsheet. It's going to do that for the authority, and then with the same logic, it's going to try to identify an operator which has a certain contract operator official name in our line. So let's say that line 1 has Acme Corporation and let's say Microsoft. So the contract authority official name is Acme Corporation. That command, we are going to try to identify that authority, which is already in the database. Then we are going to try to identify the contract operator official name, which is Microsoft, and match it to an existing node within our database. And finally, when we have identified these two nodes, we are ready to create relationships between them. To do that, we simply type merge a then the actual type of relationship, and then B. So it's very easy. First, we try to identify one node, then another node. When these two nodes are identified, we just merge them and create relationships, which is R, 2 point is contracted by. At the end, what we have is that node A and node B are linked by a is contracted by relationship. So we went through a few operations. To sum up, we first created the nodes, then we added properties to them, then we saw to do some computations, some aggregations, and then finally we just created relationships between all these nodes. So that's the few key operations that can help us, turn any spreadsheet really into a neo4j graph database, and we will be able to turn any data into a graph data. So let me now talk a little bit about the results. We now have data which is stored in neo4j, and we can visualize very easily with Linkurious. So I'm going to do a quick demo to show you how to do that. So let's say that started Linkurious. Now we have a web interface for which we can search the data, visualize it, create visualizations, share them, all of it in a secure and collaborative manner. So let's search European tenders data set, looking for interesting things. So we have a search bar right here, and I'm going to type the name of a company. It's Accenture. I can see the result change in real time until I found which is Accenture, and I can see that it's of the type operator right here. Interestingly, I can see that there are also a few other companies which have Accenture in their name, including Accenture AS, Accenture OI, Accenture A/S, and so on and so on. So it's probably that Accenture is large enough that it has operations in many countries. That's the first explanation. The other explanation is also that the data with which we are working with is perhaps not clean. It happens a lot of time, and to circumvent that problem, perhaps we could do some cleansing after that initial load of the data. But first, let's visualize Accenture. So I simply click on it, and I can see a small node. If I click on Accenture right here, I can see more information about it. So first, there's an address which is 118 Avenue de France. So there's a country which is FR. So that should tell me that Accenture, dataset is a French company. There's a number of contracts, which is 4. So I can, I know that Accenture, dataset is linked to 4 distinct contracts, and I can see, some information regarding the company. Now, if I double click on Accenture, I'm going to learn more about its role and the information related to the company, which is present in the European tenders database. So let's double click. Okay, I've double clicked on Accenture, and now I can see more information. So let's look at the graph. So we have Accenture here. I can see that it's connected to to a company called RTE, Réseau de Transport d'Électricité. So that's a first business relationship for Accenture. It's fairly straightforward. I can see that there's RTE here, there's Accenture here. First of all, there's is contracted by relationship, and then these two entities are connected to a contract. And I can see here some information regarding the contract. The contract name is Marché Tarif SI Décisionnel. The contract type is services. It has an ID, and there's more information about it. Accenture is also connected to another organization, which is Pôle Emploi. So that organization itself is connected to a contract. And here I can see more information regarding the contract. It's accord cadre portant sur des prestations d'accompagnement. So that's once again it's services, and it's also a business happening in France. So I can understand a little bit more about Accenture and its distinct relationship. So there's RTE here, Pôle Emploi here, and the final business relationship is with Department of Social Protection. So that's interesting because if I click on the Department of Social Protection, I can see that it's actually located in Ireland. So it's that should tell me that Accenture have an operation spreading across multiple countries, and this time it has two distinct contracts with Department of Social Protection. So there's the contract, there's this contract, which is for predictive analytics modeling solutions, and then there's this other contract for database support, system development, support and maintenance of the civil registration computer system. So it's very interesting because I can see what kind of business Accenture is connecting with different organizations. And if I want to, I can drill down on the data, and perhaps I want to know if the Department of Social Protection is also working with other entities. Right now I can see that it's connected to two undisclosed nodes, and I simply have to double click on the Department of Social Protection to learn more about these other nodes. So let's click on the Department of Social Protection. And I can see that all Department of Social Protection is connected to an appeal body and to a delegate. Interestingly, it sounds like the delegate has a weird address. It doesn't have an official name. It has more than 100 relationships. Perhaps it's not something very relevant. So I'm going to just remove it. Same thing for the application. I can see that it's connected to 33,000 distinct entities. So perhaps I'm also going to remove it. I can try to see if Pôle Emploi here, for example, is connected to other suppliers. So I simply click on Pôle Emploi, choose to expand, and now I'm going to try to get a specific kind of relationships. I want to view only the is contracted by relationships with operators to identify specifically the Pôle Emploi suppliers. So let's click here, and now we can see a bunch of new information which pop up on our screen. Interestingly, some nodes immediately pop up because they are larger than others. Let's click on Synapse here. Oops, Synapse, and we can see that node. We can see RM Conseil, and if you want to know why it's sized this way, I think it has to do with the initial value cost. So So these nodes have a much higher initial value cost than the rest of the data. I can see that IBM France is also connected to Pôle emploi, just like Accenture, and I can see that there's also a company called Delight, which is connected to Pôle emploi, also KPMG, and so on and so on. So it's very easy for me to see, to analyze the tenders, visualize the relationships which are underlying these tenders between different contractors and different public organizations, and to see interesting patterns emerge. For example, here I can quickly understand the types of services Accenture specialize in, and which are its competitors. If I want to, I can share something that I've found. I can with one of my colleagues. To do that, I simply have to click on the click here, save the visualization, and now I can share the visualization with someone else within my organization. I simply have to type his email or username. So it's very easy once the data is into Neo4j to visualize and to analyze it visually with Linkurious. Now I'm going to go back to my presentation with a few key takeaways that I'd like to share with you. So first, it's important to understand that you have to choose your weapon. There are different ways out there to load data into Neo4j. It's important to understand their pros and cons, to choose the right tool for the right job. Here we use the CSV import, which is fairly straightforward, but it will not be the perfect tool if, for example, we were dealing with a massive data set in the millions of lines, or if we wanted to update an existing data set. Second point is that Cypher, the query language that we just used to load the data into Neo4j, has a learning curve. It's a query language. Perhaps it's new for some of you. It will require some time to learn how it works and to use it in a good fashion. But it's important to understand that it's also very powerful. Right now, I just show you some of the stuff that can be done in using Cypher, but there's even more to it, and it's very powerful. The third point is that when you deal with graph projects, with the data modeling, with the visualization, or with the importation, you need to learn to iterate. Most of the time you are not going to get it right on the first round. Whether it's the model or the import, you will make mistakes. Some stuff that will at first sound brilliant will turn out to not be so brilliant. So you need to learn to accept to make these mistakes, to spot errors, and to improve your data, your approach accordingly. Today, for example, I showed you some example of codes, but we saw that at the end we had some names which were misspelled, and perhaps we could fix that. We could if we tweaked a little bit the import script. So that's important to understand. So finally, I'd like to share with you a few links. So there's link to import data into Neo4j. Then there's a link to a few interesting queries to spot interesting patterns into our database, and then two links: one to the open spending website where you can download the data I just used for example, and finally a link to the European data portal, which is the original source where the European 10-use dataset can be found. So yeah, you can click on these links and find more relevant information. So that's it for today. I hope that this webinar helps you understand how to load data into Neo4j and then visualize it with Linkurious. So it's not something which is easy. It requires some learning, but please bear in mind that I'm not a developer, and I was able to do that without help from my colleagues. And I'm sure that you can do it too. So I hope that you will soon try to load your own data into Neo4j and visualize it with Linkurious. If you need any help, please reach out. We'll be happy to help. That's all for today. Bye bye.